Okay, so these are typical paper 1 questions. Let's look at these. I also have question 2 here with those questions. So let's start with A, which is I think by far the easiest. So use set notation. I think this should be notations to describe the shaded region. So when you look at the set, this one here, we have everything outside B shaded, right? So this means you want all the elements except for the elements in B. So mathematically speaking, we say to say the elements outside B is the same as saying B complement, like this. So this one will be B complement. Then let's go to C. We can look at B at the end. On part B, we have everything shaded except for the intersection set, right? So we have everything shaded except for A intersection B. So now, the mathematical word for elements outside A intersection B, as you can see, we have elements outside A intersection B as the shaded region here. So to find the answer for this, or maybe to say that mathematically, to say A intersection B complement, I mean A intersection outside A intersection B, you just write A intersection B and put a complement. So this means outside A intersection B, which is this part here. So this part is the A intersection B. Then this part here is the B. This set is the B. So next we have this one here. We have the union of two sets. So we have A union B. As you can see, this is A union B, except that the shaded region is everything outside this. So now we can apply the same rule where we say all the elements outside A union B is the same as A union B complement. This is like the opposite of A union B. Then lastly, we have this one here. It's a bit unique and requires a bit of thinking. So for this one, let me just draw it again here. X and Y, and then we have the universal set there. So now to describe this shaded region, you can say you want all the elements outside X. As you can see, all these the shaded region has elements outside X, right? But then we have these other elements which are outside X. So since we don't want to include these, you can just intersect the X complement or the sets, the elements of X complement with the elements of the set Y. So once you intersect this with the set Y, then you have your answer as X complement intersection Y. In other words, you have all the elements outside X intersecting with all the elements of Y. So when we are intersecting, we only get elements which are appearing in both sets. Since if you were to use the shading method, you would have something like this. X complement would be this, and then the set Y would be this. So what has been shaded twice here is this region here. So that explains why you have this. And then on question 2, okay, so we can move on to question 2. list down the sets stated below each Venn diagram. So we have the set A here from 2023, and they want you to list down the elements of this set. So this is similar to what we looked at in question 1, except that this time around, instead of shading this region, you are picking elements in that region. As you can see, A intersection B is here. This is A intersection B. Then when we say A intersection B, we mean everything other than elements in A intersection B. So to list down this set, you can just cancel out all the elements in A intersection B and list down all the other elements. So the other elements here are, we have a B, then you have a C, then you have a D, then you have an H. So make sure you list them down in alphabetical order. If you have numbers, list them down in ascending order so that you make it easier for the marker to mark. So I'll attend to this one at the end since it's a bit different, but not necessarily hard. So now we want the elements of P complement intersection Q. So to list down this set, you have to check the elements of P complement. So this is the set P, and then when we say P complement, we mean all the elements outside P. Let me just shade P complement. So in P complement, we have all these elements except for the elements of P. And then now we want to intersect these elements with the elements of Q. So you can also shade the region Q. So this is the set Q. So if you were to shade this, you will realize that only this part here has been shaded twice. We have these lines like this, and then we have these lines like that. So in short, we want the elements which are outside Q, which are outside P, but are also in Q. So those elements are these. Now I can't even see my numbers. I think we have a 4, a 5, I think, and a 9. So this is the set P complement intersection Q. So once again, the other way of looking at this is, you say all the elements outside P, the elements outside P are these elements here, right? Except for these things here. And then intersection elements in Q. So now you want all the elements outside P but are also present in Q. So you leave these two out because they are not in Q, despite the fact that they are in P complement. So this is how you get this one. Then we have this one. This was a bit unique, but nothing you've never seen. So for this one, you have to list down the elements of A union B first. So the elements of A union B are these elements, right? But then the question wants the elements outside A union B. So the elements outside A union B are this and this. So if you are to shade A union B complement, that would be something like this. Everything outside A union B. It would be something like this. But then we have an N here. This N is telling you that they just want the number of elements in the given set. So in short, when you list down this set, you have 5 and 9. So now how many numbers do you have in this set? So that's what this n is doing there. So we have two numbers, we have a 5 and a 9, which is 1, 2. So we have two numbers, and this is the answer. This is the number of elements in this set. And then lastly, we have this one where the elements have been listed down, and then they want you to figure out the sets to which these elements belong. So let's look at the elements. So we have a D, this one here, an E, and an F, and then we have a G. So as you can see, none of these elements is in the set A. So that means we are talking about all the elements outside the set A. So in mathematics, that set is A complement. So that's how you describe this region.